Hello, Grade 5s. Welcome to today's Worksheet Cloud Grade 5 Maths lesson on how to add mixed numbers. I'm Mr. T, your maths teacher for today. At Worksheet Cloud, we're all about you having fun while you learn. And with that in mind, we've got a great new Rewards Hub feature on our website where you can earn rewards while you learn. Rewards like no more hot chocolate, great merchandise from Worksheet Cloud, or possibly even a PlayStation 5. But let's get on to today's maths. We'll come back to that later. So, fractions, adding mixed numbers. Some people call it mixed fractions, other people call it mixed numbers, but it's those ones that have a whole number and a fraction together. And it's important that you know how to add those as well as just common fractions, which is what you've done up until now. So let's have a look at what your lesson goals are for today. Pretty simple. Be able to add mixed numbers with and without carrying from the fraction. That's a bit of a mouthful, but I think it'll become clear as the lesson goes. So some of your teachers this year will not worry about when you have to carry to the fraction or from the fraction to the whole number, but I don't think that it's useful to learn just part of something when the next step is actually not all that complicated. It's best to learn it all together, in my view. So prior knowledge that will help you with this lesson: you should be able to add common fractions. You should be able to find equivalent fractions, which is important for adding common fractions when the denominators are different. And finally, you should be able to convert improper fractions to mixed numbers or mixed fractions. So, just a reminder, when we're adding common fractions, if the denominators are the same, it's pretty straightforward. We add the numerators together and we leave the denominator the same. So 1 plus 2 is 3. And that's 3 over 5. Right, when we get to the whiteboard, you'll see why, I'll explain why it stays as over 5 if you're a little bit unsure about that, and why it doesn't become 3 over 10. Okay, and when we have different denominators, something that you should also have been able to do by now, but it always gets better the more you practice it. So we've got a situation here where we've got two denominators that are different. And one of the important things when adding and subtracting fractions is that you have to have the same denominator before you add or subtract. If they're not the same, you can't actually add and subtract them. So first step is to make them the same. Now in this particular case, I can see that 5 could easily be converted to a 10 if I times it by 2. So what I'm going to do is I'm going to double the denominator and the numerator on the right hand side, and I get 4 over 10. So my first fraction remains unchanged. I've simply rewritten it over there. My second one, I multiplied the bottom by 2 to get 10, and I multiplied the top by 2 to get 4, because what you do to the bottom, you do to the top. Otherwise, you no longer have an equivalent fraction. You have something different. So I'll run through a little bit of equivalent fractions when we get to the whiteboard. But once you've got it, the denominator is the same. It's the same as what it is above. You add the numerators and leave the denominator unchanged. Finally, a slight variation on this is where you have denominators where you can't change one to become the other, and you have to actually change both the denominators. So I will go through how we do this on the whiteboard as well. But if I look at those two numbers, I need 2 and 3, the denominators. I need to find something that both 2 and 3 can fit into. So my mind immediately jumps to 6, because 2 4 6, 2 goes into 6, and so does 3. So I'm going to convert both of those to fractions with a denominator of 6. So if I look at the one on the left-hand side, to make it 2 into 6, I've got to multiply by 3. What I do to the bottom, I do to the top. It becomes 3 over 6. And on this side, I've got to times by 2, and I get 3 over 6 and 2 over 6. Once we've done that, last step is same as we've done before. Simply add the numerators and not the denominator. Okay, I am going to jump across to the whiteboard now and run through a couple of those things. Let's go across to my whiteboard. There we go. All right. So first thing I want to do is just have a look at equivalents and what they mean. All right, so I've drawn a fraction over here, and if you like, that is a half. Oh wait, let me color in a half. All right, so I've got half of my fraction because I've got one piece out of 2. But I could, oopsie, let me put my ruler on. I could do that and make it 4 pieces. Let me leave the middle one purple. All right, so I now have 4 pieces, and oopsie, 2 of them are colored in. So the purple still colors in, but now 2 out of the 4 pieces are colored in. So it would be true for me to say then that I have 2 out of 4, and that 1/2 is the same as 2/4. Right, but I could then again divide each of these halves or quarters into more pieces. So now if I'm having a look at it over here, I've got 1, 2, 3, 4 colored in, still the same amount colored in, and it represents the same amount. I've got 4 colored in, and in total there are 8. So it is also true for me to say that 4 over 8 is equal to 2 over 4 is equal to a half. So each of those is equivalent fractions. Let me see. I'm going to do something slightly different here. So I'm going to erase those 2 lines, and I'm going to erase those 2 lines, but I'm going to leave the same amount colored in. But instead of dividing it the way I did it before, I'm going to break these 2 side pieces up into 3 each. All right, because up until now I've just been doubling each time. So what I've done here now is the amount that's colored in, 1, 2, 3, is 3, and the total number of pieces is 6. So it's also true for me to say that that is an equivalent fraction. All right, so you've just got to be able to find different ways to represent, and the key thing to remember is what you do to the bottom, you do to the top. Otherwise, your fraction will change. Okay, now there are a couple of ways this gets asked, and I will briefly touch on those. So one of the ways is they'll say write down an equivalent fraction. One of the ways is within adding or subtracting, just checking that you can get to the right equivalent fraction. But sometimes they'll leave a missing number. So 3 over 7 is equal to something over 14, and they want you to find out what is the missing number. Now with these ones, the way you want to go about it is to always work from what you do know to what you don't know. So I know the left and I know the bottom. So I'm going to work from the left to the right, and I'm going to start with the bottom. I ask myself, what did I do to a 7 to turn it into a 14? I doubled it, times it by 2, and what you do to the bottom, you do to the top. So if I double the top, I'm going to get 6, and so my final answer there is 6 over 14, and those two are equivalent. You might just as easily have one where it's the other way around. So let's pick 16. Let's pick 3. No, actually, sorry, I'm going to use a slightly smaller number just because I'm aware that we don't want to make it too complicated for you. So we've got 8, and then we're going to say, okay, we've got 24 at the bottom. No, okay, I don't want to, yeah, oh well, we can work that way. It's the same way as before, but it's fine. Okay, what did I do to 8 to turn it into 24? 8, 16, 24 times by 3. Must do the same to the top, times 3 gives me 9. So those two are equivalent fractions. All right, this time we're going to leave the missing number on the left-hand side. 6, 18, and 6. All right, and we want to find the missing number. This time we know what's on the right, and we know what's on the bottom, so we're going to work from the right to the left, and on the bottom we're going to start to find our rule. What did I do to 18 to turn into 6? That's tricky because we got smaller. Well, we can only use times and divide. Times is always going to make us bigger, so divide is what we're going to use. So I'm going to ask myself how many 6's fit into 18. 6, 12, 18. So I divided it by 3, which means I've got to divide the top by 3. How many 3's in 6? It's 2, and so my final answer then is 2 over 6. So always, as long as you just remember to work from what you know to what you don't know, you should be comfortable. Okay, just to practice with adding common fractions and just a reminder of why our denominator doesn't change. If I'm having a look over here, I've got 2 over 6, and I'm going to add 3 over 6. So let me first of all start by coloring in my 2 over 6, and now I'm going to color in my 3 over 6. And the question is, what am I going to end up with? Well, if I start with the drawing, I'm going to put the 2 in, and now I've got to add another 3 in, which means that I'm left with a total of 5 over 6. All right, and that is the correct answer. The reason we don't double it is because we're looking at at pieces that are sixths. All right, so if we said that the answer was, and please note that this is wrong, if we said the answer is 5 over 12, I'm going to actually write there wrong so no one gets confused. Right? If we wrote 5 over 12, 1, 2, 3, 4, 5, we're looking at a whole that is quite a lot bigger than what we were looking at over here. Or alternatively, if you broke it up into smaller pieces, so you simply halved each of those. Let me just move it a slight bit across so we don't get behind my picture. All right, did I put the ruler on? Okay, so if we kept the whole the same size, but we made it into 12 pieces, and then we tried to color it in, 1, 2, 3, 4, 5, you'll see that that amount is not the same. So those are not equal. Right, so that's why we don't add the denominator or change the denominator. So, okay, I'm going to erase all that and we're going to have a look at what do you do when the denominator is different. Let me erase the wrong stuff before anyone gets confused. Okay, so I did give you an example where we had the same denominator. What if we have different denominators? So let's pick 1 over 9 plus 2 over 3. All right, well, we need to make our denominators the same. I notice that I can do something to my 3 to make it into a 9. So I can times that by 3 times 3, and what I do to the bottom, I do to the top. I'm now going to write it next door to it. I'm going to keep the first part the same. I'm simply rewriting the fraction that I had at the beginning. My next one, 2 times 3 is 6. 3 times 3 is 9. I'm now looking to add these same denominators, which is easy enough. So my numerators I add, my denominator stays the same. And that's your final answer. Finally, we get ones like this. 1 over, let's go with 3 plus 1 over 4. All right, now these two, I can't make one of them into the other. So I've got to look for a number that both of them fit into. Now, you might be good enough at maths that you recognize that the answer is going to be 12 straight away without even doing any workings. But if you're ever in a situation where you're not sure what the lowest common denominator is, then you can just use this method. So when we're talking about something that's common, we want something that's shared, and lowest common multiple is something in the times table. So I'm going to start off by writing down the first few numbers of my times table. Oops, I switched times tables there. 21, 24, and 4, 8, 12. Now usually I'd stop there because I've already found one that's in both, but I want to just go on a little bit. Now any 2 numbers or 3 numbers will always have many common factors, but we want to go with the multiples. We want to go with the lowest common multiple, the smallest number that goes into both. The reason for that is because if we pick a bigger one, our answer is not going to be the simplified fraction. And if your teacher wants you to give your answer in a simplified form, then you're going to have to simplify, which is then an extra step of work and another place where you could make an error, which is not necessary. I like to keep chances for mistakes down to a minimum. All right, so I notice that now I want to have a denominator of 12. So what can I do to a 3 to make it into a 12? 1, 2, 3, 4 times by 4. What I do to the bottom, I do to the top. What can I do to the 4 to make it into 12? 1, 2, 3, so times by 3, times by 3. So my first fraction becomes 4 over 12. That's an equivalent. My second fraction becomes 3 over 12. I now have two fractions that are over 12, which means I can add them. 4 plus 3 is 7. 12 is my denominator. So that is the three forms of common fractions. What we're going to be looking at now is mixed numbers. But there's one final just piece of revision to go over before we look at that, and it's how to change improper fractions to mixed number. So just a reminder that an improper fraction is one where the numerator is bigger than the denominator. So this is an improper fraction, and I want to turn it into a mixed number. A mixed number is where you've got a whole number and a fraction. Okay, so I've got 5 quarters. So let me start off by coloring in my 5 quarters. What you'll notice is that I've got a full 1 over there, and that becomes a whole number, and I'm left with 1 over 4. And that is the mixed number version of 5 over 4. So I've changed my improper fraction to a mixed number. That's all very well and good if you're looking at things like quarters, but it's not super useful if you're looking at like a really big number. Like let's say you were looking at 86 over 85. Are you really going to draw a shape that has 85 little pieces and then color them all in? That would take forever. So there's another way. Let's look again at the 5 over 4. Shift you a little bit across. And we ask ourselves, how many times does 4 fit into 5? Well, if I do my 4 times table as many times until I can't fit more. 4, 8. 8's too big, so I can only go with 1. So that's my whole number. How many do I have left over? Well, I had 5. I've used 4, so I've got 1 left over. And there's my fraction. So using the same logic, 85 goes into 86 once, with 1 left over, and the denominator remains unchanged. One more, because both my examples had a 1 as the whole number, and I don't like to leave a pattern that might confuse people. You might always think it's going to be 1. So let's go with 12 over 5. How many times does 5 go into 12? 5, 10, 15 is too much, so it's 2. I used 5, 10. I used 10 of the 12, which means I've got 2 left. So there's my mixed number. 12 over 5 is equal to 2 2/5. Okay, we are going to do some practice, but just before then, I think it's time for a Nomu hot chocolate break. Let's be honest, studying sucks. But here at Worksheet Cloud, we make it suck way less. In Worksheet Cloud, you can earn avatars, sidekicks, collectible coins, and then level up all while studying. Plus, we've just added our most exciting feature to date, the brand new Worksheet Cloud Rewards Hub. With Worksheet Cloud Rewards Hub, you can earn epic rewards and unlock entry tickets to win real giveaway prizes, including a Sony PlayStation 5, some yummy Nomu hot chocolate, and some fresh Worksheet Cloud merch. The more questions you answer, the more points you earn, and the more rewards you unlock. Worksheet Cloud makes your studying easier with video lessons, practice exams, practice questions, and study notes. In other words, we're your go-to place for all your studying. Ask your parents to sign you up at worksheetcloud.com today. So good. Makes the study break so much better. Okay, let's shift you down a little bit and let's do some practice before we go on to some word problems. Check that you're on the same page as me. We need to actually go back to our whiteboard quickly because I did have a worked example here. Not our whiteboard, our slides. Okay, right, so when we are adding mixed numbers, so there we go, we've got 1 1/5 plus 2 2/5. Nice that the denominators are the same. This is where we'll start, and yeah. Well, I'm going to go 1 plus 2 is 3. And then I'm going to go, well, 1/5 plus 2/5 is 3/5. And it's literally as simple as that. Straightforward, you just have to add the whole numbers and then you have to add the fraction part. So, of course, you're going to come across ones where the denominators are different. This looks very much like the example we just did, except with mixed numbers. So I'm going to say, well, I can't add thirds and quarters. I have to first make the denominators the same. So notice that I have done nothing with my whole number. My whole number stayed exactly the same. 3 and 3 and 2 and 2. The only thing I changed was the fraction part, and we find equivalent fractions in just the same way as we've done before. So I had to make this into 12ths, so I times by 4, became 4 over 12, and I had to make this into 12ths, times by 3 and 3, became 3 over 12. And from then on, it's just what we've done before. 3 plus 2 is 5, and 4 plus 3 is 7, and over 12. And it's as simple as that. Now, I'm going to do some examples with this on the whiteboard, and then we're going to come to where it's a little bit more tricky, and that is the situation where you end up with an improper fraction over here. Right. Jumping back to the whiteboard. Okay, here we are. Right, okay, so let's give an example. I've got 1 and 7 over 12 plus 3 and 2 over 12. Right, so I'm just going to double check that we are. Yes, you are seeing what I want you to see. Okay, so this is one of those situations where our numerators are already nice and they're the same. So we don't need to change that. So I'm simply going to go, what's 1 plus 3? That's 4. I'm going to know my answer is going to be over 12 because we're looking at 12ths. 7 plus 2 is 9. And there we go. Some of your teachers will want you to simplify these answers. And so what that means is we've got to reflect this in the simplest possible form. And I notice that it's not in its simplest form now. I'm going to do this for one of them only because it's not what we're actually practicing today. Simplifying is a different skill that you should have or you should already be practicing. Okay, when we simplify a mixed number, the whole number stays the same, nothing changes. Now I'm going to ask myself, what can go into 12 and into 3? What's a common factor? Well, 3 goes into 9 and into 12. 3 goes into 12 4 times, and 3 goes into 9 3 times. So 3 over 4. And that's actually the simplified answer, which some of your teachers will want. And the reason this is true is because this and this are equivalent fractions. Okay, let's do another one. Right, if you're feeling comfortable, why don't you pause the video and try this one on your own? I'm feeling comfortable. I'm going to carry on. Okay, well, we look first of all at our whole numbers. 5 plus 2 is 7. We know it's going to be over 13 because they're the same already. 1 plus 4 is 5. There's our answer. And that is already a simplified one, although I wouldn't have simplified it anyway. And the trick to know is that you can know if it's a simplified number because the denominator is already a prime number. Just a little BTW. Okay, let's have a look at slightly different ones. Let's have a look where we have to change one of the denominators. So shifting those ones out, let's look for the new ones. Right, so I've got 4 1/4 plus 2 1/2. I need to make my denominators the same before I add them. So I'm going to do that by adjusting this one. I'm going to multiply the top and the bottom by 2. My first number stays unchanged. It is still 4 1/4. My second number, the whole number is still the same, but now it's 2 over 4. Right, because I now have the same denominator, I can go ahead and add them. So 4 plus 2 is 6. 1 plus 2 is 3 over 4. Final answer. What's the mistake that people make the most? Okay, yes, the mistake that people make the most is when they're converting the denominators to be the same over here, then they forget to transcribe or move across the whole number as well. So please don't make that mistake. Okay, one more of this format. Oh, actually, let's throw in something like this. No, not over 12. Let's go with 3 over 6. Okay, so what I've done now is I've given you a situation where you've got a whole number on one of them and you don't have a whole number on the other one. In truth, there is a naught here, but we don't write it because it's a bit of a waste of time. There are no whole numbers, it's just the fraction part. Okay, well, before I add them, I need to make my denominators the same. I notice that if I double this, I can get the same denominator. So I've got, changing colors. That's a 5, and 3 over 12 is plus, and this one becomes 6 over 12. Add my whole numbers. 5 plus nothing is still 5. Add my numerators. 3 plus 6 is 9 over 12. There we go. Right, so we've got those where we've changed it, and now we've seen what happens when there's no whole number on one of your numbers. So it's a mixed number and a common fraction, easy peasy. I love how people say that. They say something's easy, but when people say something's easy, what they're really saying is, that's easy for me, or I find that easy. People can say something like, it's easy as pie, and I'm going, I'm not that great in a kitchen. That doesn't sound easy at all. So it's an odd thing to say when we say something is easy. I find it easy. I hope you do, or at least that you're practicing it and it's becoming easier. I'm going to look at a couple where we have different denominators, but both need to change. So 6 and 2 over 3 plus 3 and 1 over 4. 3 and 4 are quite a commonly used set that teachers use at this age when they are looking for changing both in a common denominator, because it's one of the smaller sets of numbers where you can find a common denominator. So if I want to find one and I'm not sure, I happen to know what it is, but let's just practice. 3, 6, 9, 12, 15. I normally start with 5 of them, and if I need more, then I go back and add more. So 4, 8, 12, and I'm going to stop there because I've seen that 12 is common. Okay, so I know I want my denominators to be 12, so my 6 stays the same. And in fact, I know that it's going to be over 12, and I know that my 3 is staying the same, and it's going to be over 12. It's just the numerators that are going to change. So what did I do to a 3? I times it by 4, times by 4. 8 over 12, and what did I do to the 4? Times by 3, times by 3, 3 over 12. Now that I've got that in place, I can add my whole numbers. 9 and 11 over 12. Okay, one more of those. Another combination that comes up fairly often. Let's make it an even bigger number. 13 and 1 over 5 plus 7 and 1 over 4. Right, well, first things first, we need to look for a common denominator, something that both 4 and 5 can go into. So I'm going to go 5 Yes. 5, 10, 15, 20. The better you are at your times table, the easier it is to see what your common denominators are going to be. And there we got it. 20 is our common denominator. So 13 and something over 20 plus 7, something over 20. What did I do to my 5 to make it into 20? Multiplied by 4. What you do to the bottom, you do to the top. It becomes 4. What did I do to my 4 to make it into 20? Times by 5. Which gives me 5 over 20. Now that my denominators are the same, 13 plus 7 is 20. 4 plus 5 is 9 over 20. Final answer. All right. Now we come to the part I was talking about with the mixed numbers where things don't work out so nicely. I'm going to do a couple with these, and then we're going to go across to some word problems if we've got time. Okay, so let's say we've got 3 3/4 plus, and I'm going to keep the denominators the same for this one, 2 3/4. And now I want to add these together. Oh, well, this is easy. Well, 3 plus 2 is 5. Denominator staying the 4. 3 plus 3 is 6. Here's where our problem comes in, is that we've got a mixed number which has an improper part to it. And when you've got a mixed number, it must be a whole number and a common fraction. So we've got a problem that 6 over 4 is actually an illegal maths maneuver in a mixed number. So how do we get rid of it? Well, the answer is actually fairly simply, okay, I'm going to make a little box underneath, and we're going to look at just 6 over 4. If we had the fraction 6 over 4, and we were told you must make that into a mixed number, we would say, how many times does 4 go into 6? Once. What was left over? 2. And there we would go. So what we've done is we've changed 4 over 6 into a mixed number. Well, that's all very well and good. So we can say, and we would never write it like this, but we could say that we had 5, and then we had 1 and 2 over 4. But these two are actually both supposed to be together. So what we would really do is carry that 1 and add it to my whole numbers. So that would become 6, and I'm left with 2 over 4. So that's the final answer, 6 and 2 over 4, if you want to simplify 6.5. Okay, let's do another one of those. So it works the same if you've got different denominators, just the first step is then to make the denominators the same. 12 and 5 over 7 plus 2 and 3 over 7. Okay, step 1, let's see what happens when we put it all together. 14, 8 over 7. Right, and again we've got the situation where we have an improper fraction. So if you can do this in your head, I'll draw my box again at the bottom, where I go 8 over 7, and I don't mind if you doodle this on the side. I'm sure teachers won't mind either. And that's just another quick note. If you ever are doing workings out on the side, don't rub them out. As a teacher, if I can see what your workings are on the side, obviously do them as neatly as possible. But if I can see them, then sometimes if you have made a mistake, I'm able to tell where you've made the mistake, and then I can give you guidance on how not to make that mistake or what it is that you need to do differently. 7 goes into 8 once with 1 left over and 1 over 7. So I'm going to add another 1 to the 14, and it becomes 15. My leftovers were 1, and there's my final answer. Right. The more you practice, the better you're going to do. We're going to do one more, and then we're going to go across to our word problems. Right. Also, just as a note, you'll always have a situation where this is only going to be a 1 and you carry it. It's never going to be more than that. But don't worry about that. Just follow the same pattern that we've been doing. Okay. This time I will give you with a different denominator. Let's say 1 3/4 plus 2 2/3. So again, step 1. In this situation, we have to make the denominators the same. We've used 4 and 3 quite a few times, so I'm actually not going to show you the times tables, but it's going to get to 12. So what do I do to my 4 to make it into 12? I times by 3. What do I do to my 3 to make it into 12? I times by 4. So my new numbers are 1 and 9/12 plus 2 and 8/12. Shift across a little bit. Okay, so we've made our denominators the same. Now we can add them. 1 plus 2 is 3. Denominator stays the same. 9 plus 8 is 17. Now we have that problem with the improper fraction part. So we ask ourselves, how many times does 12 go into 17? It's once. I add that 1 to my 3. I used 12 out of the 17, which left me with 5. And there's my final answer. Right, I hope this is starting to become a little bit smoother. Let's go up to the 3 word problems I've got for today. I don't know that these are the best word problems. Sometimes it's difficult to come up with a nice one that matches the subject matter for the day. All right. A recipe requires 2. Also just remember, if it's a word problem, you have to have a number sentence, then workings, and then an answer sentence in words. So we're going to start with our number sentence. A recipe requires 2.5 cups of flour, 2.5 cups, and 1 3/4 cups of almond flour. I don't know what recipe this would be, but let's go with it. How many cups of ingredients will be in the bowl, assuming that that's just the 2 that are in the bowl? Okay, so our number sentence would be 2.5 plus 1 3/4. There's our number sentence. We now need to do our answer sentence. So, or our workings. So now we can go, all right, well, 2.5 plus 1 3/4. I need to make my denominators the same first. I notice that I can double this one. So that becomes 2 2/4 plus 1 3/4. So that doesn't change. The second one is still the same fraction. Now we can go to our answer. Well, we've got 1 plus 2, or 2 plus 1 is 3. 5/4. We sit with the situation of our improper part, which we just need to fix quickly by converting it to a mixed number. We ask ourselves, how many times does 4 go into 5? It's 1, so we carry the 1 over there to the to the 3, so that will become a 4 now. What was left over was 1, and there's our final answer. We had 4 1/4 cups of ingredients in the bowl, which we now need to write. We had 4 1/4 cups of ingredients in the bowl. Okay, next question. A shot put participant. Let me move you up. A shot put participant had a bad first throw. Her next throw was 3 2/3 of a meter better. Her final throw was 4 4/5 better than the second one. All right, so we've got to figure out how much further was her final throw than her first. So it doesn't actually matter how far it is. It's just we're checking how much further it is. All right, so let's have a look. We had 3 2/3. Her final throw was 4 4/5. All right, there's our number sentence. We now need to do our workings, so I'm going to rewrite it like that so I can start my workings. Different denominators means our step 1 is to make the denominators the same. Perhaps you are not familiar with what will be the lowest in these two times tables. So let's write it down. 3, 6, 9, 12, 15. I normally just start with 5. 5, 10, 15. Ah, there we go. 15 is in both of them. So I ask myself, what do I do to the 3 to make it into 15? I times by 5, times by 5, which means that the first one becomes 3 and 10 over 15. For my second fraction, I'm going to say, what did I do to a 5? I times by 3, do the same to the top. So that becomes plus 4 and 12 over 15. Now that our denominators are the same, we can go ahead and add. So 3 plus 4 is 7. Denominator stays the same. 10 plus 12 is 22. And we sit with our situation of an improper fraction over there in the final space, which we need to sort out. So we're going to ask ourselves, how many times does 15 go into 22? Once, which makes we carry to there, so we now have 8. And what do we have left? Well, we used 15. So if you need to count, 16, 17, 18, 19, 20, 21, 22, we have 7 left. That's why bonds is very good. If you are very familiar with your bonds and you've practiced your numbers, you wouldn't have to count on your fingers. You could just know the answer. Right, we have one more. Dash and Pirate's parents went out. We think of our kids as our dogs. So this is Dash and Pirate are my dogs. Dash and Pirate went out. They're sleeping next to me now. The dogs spent the time until we got home as follows. 4.5 hours of sleeping. Oh, I think being a dog must be so cool. You get to do lots of sleeping and eating and everything's exciting. All right, so, in my previous one, I would get marked down by my teacher because I didn't put a word answer. So I would have to say, her final throw was 8 7/15 meters better than her first. Okay, managed to get that, otherwise I would have lost marks. Okay, so what did we say? We said 4.5 hours. 4.5 hours sleeping plus 1 1/3 of an hour looking out the window. Oh my goodness, we've got a third one. So 1 1/3 and 2 5/6. Oops. 2 5/6 of an hour chewing my slippers. That's naughty. And how many? So then that's when we came home. So how many hours were we out? Okay, we have for the first time a situation where we have 3 different denominators and we need to make them all the same before we add. It's just the same as when we're adding two terms, but with 3 we just need to make sure that all 3 are the same. So I happen to be able to, you could sit and draw and write down the first few numbers of each of their timetables until you find that's what's in, what they're all in. But I noticed that 2 and 3 are also fit into 6. So I'm actually going to just leave this one the same, and then I'm going to change the other ones to that. So what did I do to a 3 to make it to a 6? Times by 2, so that becomes 1 and 2 over 6. And what did I do to this? I times by 3, so that becomes 4 and 3 over 6. All right, now I've got my denominators the same. This shouldn't be too complicated. 4 plus 1 is 5, plus 2 is 7. So 7, and we know our denominator is going to be 6. 3 plus 2 is 5. 5 plus 5 is 10. All right, and we sit again with our situation of a mixed number over here. So we ask ourselves, how many times does 6 go into 10? It's 1, so we carry the 1. 1 plus 7 is 8. We had 4 left over 6. And there's our final answer. We just need to put it in a word sentence. We were out for long. Shame, poor doggies. I'll just put we. 4, 8, and 4 6 hours. Okay, I think that's where we're going to leave it today. Practice is what makes you good at maths. So that's the important thing. Now that we've done it, it's important that you practice it. Otherwise, the lesson isn't going to stick and the methods are not going to be something that becomes part of your maths ability. So once you are done watching the lesson, click on the link below the video in the description to download a worksheet from Worksheet Cloud where you can practice what it is that we've been going through today. And don't forget to get your parents to sign you up for Worksheet Cloud so that you can access all of their worksheets, not just in maths, but in other subjects as well. And more particularly, that you can access that rewards page where you can win cool prizes like merchandise from Worksheet Cloud, or Nomu hot chocolate to sweeten those study breaks, or even possibly that PlayStation 5. Who knows? It could be you. Have a wonderful day, grade 5s. I'll see you again soon. Bye.